In this section, we're going to talk about the distance formula. The distance formula. Okay. If you have 2 points, one x1, y1, and our second one, x2, y2, right here. You want to find the distance between them. How far is it between these 2 points? Let's put in some coordinate systems. Now, the reason this point is called x1, y1 is because when you look straight down, you see x1. And when you look straight across, you see y1. And the reason this point over here is x2 is because when you look straight down, you see x2. And if you happen to look straight across, you see y2. Okay. Try to get rid of these dotted lines. Now, Pythagoras is going to help us with this one. We want to know this distance. Well, if we make a right triangle by going like this and like that at a right angle, we know what this point is, for example. That point is, well, you look straight down, you get the x value. You look straight across, and you get the y value. It's x2, y1. Okay. Now, this distance in red, this distance here, it's exactly the same as this distance. And with any vertical distance or displacement, the distance is the top value minus the bottom value. Somebody asks you, how far is it from 7 to 11? I'm pretty sure that, you'll say 4, but somebody asks you how you calculate it. You should say the top minus the bottom. So this distance here is y2 minus y1. And if somebody were to ask you for horizontal displacement, how far is it from 2 to 9? Fine, you know it's 7. But how do you get that this distance is 7? And the answer is it's the right number minus the left number. But that's only for vertical and horizontal. Now, this distance is exactly the same as that distance, which is right minus left. It's x2 minus x1. And let's call the distance that we want d. Now, Pythagoras will be really helpful here. Pythagoras would say that d squared is equal to this squared. Now, to be honest, I prefer to call that the change in x. And I prefer to call this the change in y. Delta means change. Triangle, the Greek letter delta, means change in. The change in x. Okay, d squared is equal to the change in x all squared plus the change in y all squared. That is what Pythagoras would say. Well, if d squared equals what it says on the right side of the equal sign, then d, the distance in question, will be plus or minus the square root of delta x squared plus delta y squared. Like I said, plus or minus. The thing is, distance, so mathematically, from here to here, we get plus minus. But distance is never negative. So d is equal to the square root, not plus or minus. Well, it's plus, but definitely not the minus. This here is the distance formula. It's the change in x squared plus the change in y squared, square root. Okay. So let's work a couple of numerical problems, or at least one numerical problem, and then we'll do some more involved problems. I give you 2 points, and we want to find the distance between them. Now, sometimes the change in x is positive, sometimes the change in x is negative. But since we're squaring it, it doesn't matter if it's positive or negative. Okay. So, find the distance between 3, 5 and 7, 2. The distance is the square root of the change in x squared plus the change in y squared. Well, if x goes from 3 to 4, the change was 4. It's positive 4, but it doesn't matter, positive, negative. When you square it, it's all positive. What's the change in y? Y goes from 5 to 2. Well, it went down 3. And again, you can be sloppy and just say, oh, the change is 3. So it doesn't matter if it's plus or minus, because when I square it, I always get positive. And 16 plus 9 is 25, and the square root of 25 is simply 5. And that one's done. What if I want to find the distance between 2, negative 4 and negative 5, 3? D is equal to the square root of the change in x squared plus the change in y squared. And I promise, in here I'll put the change in x, and in here I'll put the change in y. Okay, well, if you go from 2 to negative 5, or negative 5 to 2, the question is, how far is this? Whenever the signs are different, just add the absolute values. Just add 5 and 2. Why is that reasonable? Because from negative 5 to 0 is 5, and from 0 to 2 is 2. And like I said, if you just add the absolute values, you'll get them. If you go from 4 to negative 3, 4 plus 3 is 7. Okay. If you go from negative 4 to 3, you want to draw it vertically because it's y's, draw it vertically. Here's 0. That distance is 4. That distance is 3. Whenever you subtract two numbers that are on opposite sides of 0, just add the absolute values. Just be careful. Sometimes it'll be negative, sometimes it'll be positive. We have the luxury here of ignoring that. Why? Because we are squaring these numbers. We don't care if it's 7 or negative 7. Now, since I am taking the square root, and I know the square root of 7 squared, this is basically underneath the radical. You add something to itself 2 times, you get 2 times that. Now, I know the square root of 7 squared. It's 7. And I do not know the square root of 2. There it is. Some people, I think they're making it harder. They'll say 7 squared is 49 plus 49 is 98. And then they have to ask themselves, what's the largest number that goes into 98 that you know the square root of? And you're not going to believe this, but it's going to be 49. 2 times. So you can take the square root of 49 separately and then multiply that by the square root of 2. And there it is. But that's exactly what I had before. And I didn't have to know what 7 squared was. I didn't have to know what 7 squared plus 7 squared was. That's too hard. So, going to give you 3 points on a triangle. 8, 4. That's 1 point. The other point is going to be 3, 5, and 4, 10. 3, 5, and 4, 10. We want to show that this is a right triangle. Well, 3, 5, we'll call right here. 4, 10 will be up here. And 8, 4 will be right here. So we want to show that this is a right triangle. And you can't say, oh yeah, of course, it looks like a right angle. And come on, that can be 89.3 degrees. Doesn't have to be 90 degrees. Well, the way to show that it's a right triangle is to find this distance and this distance and that distance. You know what? Show that this squared plus this squared is that squared. That's the only way you get a right triangle. There's no other way for that to happen. There's no way that when you square 2 of those lengths and add them up, you get the third one squared, unless it's a right triangle. There's absolutely no way. So this is 3, 5. This is 0.84. And this is 4, 10. 1, 2, 3. Okay, let us find distance 1. Call it D1. Well, from 3 to 4, the change is 1. Square it. The change in x is 1. From 5 to 10, the change is 5. Square it. So you get 1 plus 25. You get the square root of 26. We now have D1. It is the square root of 26. Let us find distance 2. 2. It's between this point and that point. If x goes from 4 to 8, the change is 4. Square it. Plus. If y goes from 10 to 4, it went down 6. But negative 6, positive 6, all the same for us, because we're squaring. 4 squared is 16. 6 squared is 36. You add them up, you get 52. Square root of 52. This 52 is 4 times 13. 4 being the largest number that I know the square root of that goes into 52. Well, square root of 4 is 2. The square root of 13, I don't know. Boom. That distance is 2 square root of 13. Now let us find distance 3. Square root. Well, x goes from 3 to 8. Change 5. Square it. Y goes from 5 to 4. Went down 1. Don't care about plus or minus 1. You know, whether you square minus 1 or 1, you're going to get the same answer. Well, this is 25 plus 1. This is the square root of 26. Okay. Not only are we getting we haven't shown yet that it is a right triangle, but we clearly have an isosceles triangle, because 2 sides are the same. Okay, so is it a right one? Now, when it comes to 26, the largest number that I know the square root of that goes into 26 is 1. So you can't simplify that. The square root of 26 squared plus the square root of 26 squared. Now, there's only one way this is going to be a right triangle, and that's if those two sides I just wrote down are the smallest one. You can't have two. Remember, the hypotenuse has to be the longest side. Not only that, it has to be longer than the other sides. That is, you can't have two sides that are longest in a right triangle. There's only one. And it's going to have to be 2 times square root of 13. It's the only different one. Is that true? If it is, we have our right triangle. Well, when you square the square root of 26, you get 26. When you square the square root of 26, you get 26. And when you add those up, you get 52. When you square a product, you square them separately. When you square 2, you get 4. And you square them separately and then multiply the answers. When you square the square root of 13, you get 13. And yeah, 4 times 13 is 52. We do, in fact, have a right triangle. And it's isosceles. But that doesn't mean it's not right. A right triangle. Are all right triangles isosceles? Of course not. Think of the 3, 4, 5 right triangle. The 5, 12, 13 right triangle. The 7, 24, 25 right triangle. I always forget that one for some reason. Suppose you want to find the area of a circle that contains the point 9, -4, and the center is -3, 5. Suppose you want to find the area. Well, the area of every circle is pi times the radius squared. Well, pi is pi. We need to find the radius. Well, here's the deal on this one. Don't really have to draw it, but we will. Here's -3, 5. That's the center. And our point on this circle is when x is 9 and y is -4. That's a point on the circle. One big circle. What you need to, so there it is. What you need to remember is that from the center to any point on the circle, that's R. That's R. So basically, we want to find the distance between those 2 points. We want to find the distance between those 2 points. And you didn't have to draw it. If you have the center and you have a point, the radius is the distance between those 2 points. The center point and the point on the circle. And instead of calling it D for distance, we'll call it R for radius. R, the distance, is the square root of change in x squared. Well, if x goes from -3 to 9, if x goes from here to here, Their signs are different. Just add 3 and 9 and you'll be done. This distance is 3. That distance is 9. Okay, let's try that again. From negative 3 to 0 is 3, and then from 0 to 9 is 9. 3 plus 9 is 12. The change in x is 12. Square it. Plus the change in y. Go from 5 to negative 4. It's a change in 9. From 5 to negative 4. From 5 to 0 is 5, and from 0 to negative 4 is 4. Or if you prefer, from negative 4 to 0 is 4, and from 0 to 5 is 5. 4 plus 5 is 9. Now, if you want to be slick, you can factor out what goes into both of those numbers, the largest number, and it's 3. 12 squared is 3 squared times 4 squared, plus 9 squared, which is 3 squared times 3 squared. So you can factor out, or 3 squared. The square root of 3 squared times the square root of 4 squared plus 3 squared. Now you have to start remembering these special numbers. It just makes life so much easier. 3 squared, square root of that is 3 times. Well, 4 squared plus 3 squared. 3 squared plus 4 squared. That's 5 squared. And the square root of 5 squared is 5. I never squared 9. I never squared 9. I never squared 12. I never added them together. I multiply numbers like 3 and 5. Always take the easy way out. That distance is 15. What distance? The distance from the center to the point on the circle. In fact, the distance from the center to any point on this circle. Unless we made some silly mistake, that distance is 15. That distance is always 15. 15, 15, 15. So you can use the distance formula to find the radius of a circle. In fact, this last problem, they wanted us to find the area. They wanted us to find the area, which is equal to, so let's write it here, the area is equal to pi times r squared, 15 squared. Well, 15 squared is 225 times pi. That is the area of that circle. So we found the radius to help us find the area. Now here's a nice problem. Suppose you have this right triangle, and this is 10. And through this point, you draw the altitude. An altitude means you're going from this point to some point on the opposite side. But it's a special point on the opposite side. It's the one where that line will be a right angle. I don't know if I said it. Initially, that was a right triangle. That is, you start off with a right triangle, and whether it's a right angle or not, down here, when you draw the altitude, you meet the other side at a right angle. Okay, so you have that. And you are given that distance is 6. And that this distance, actually don't even have to be given that one. You're not given that one. Okay. And their instruction is, basically find all the lengths. That is, find this one, and this one. Okay, find x, y, and z. Find x, y, and z. Well, we have 3 right triangles. The upper one, the lower one, and then the whole triangle. For the record, let's be crystal clear. When I say the upper one, I mean this one. And when I say the lower one, I mean that one. And the whole one, the whole thing. Okay, so we have 3 right triangles. Let us look at triangle number 2. Let us go to triangle number 2. Why number 2? Because in triangle number 2, we know 2 of the sides. One side is 6 and one side is 10. Let's draw it over here. That's the right angle, 6 and 10. But you know what? This number 6 is 3 times 2. This number 10 is 5 times 2. 3, 5. 3, 4, 5 right triangle. Oh, you mean this one is really 4 times 2? Remember, the larger side has to be the hypotenuse. You can get it that way. That x is 8. Or, if you really want to do it painfully, you can go x squared plus 6 squared is 10 squared. X squared is 10 squared minus 6 squared. 10 plus 6, 16. 10 minus 6, 4. 16 times 4 is 64. X squared is 64, so x is plus or minus 8. But since it's the length of a side of a triangle, it's not negative, so it's positive 8. Okay, so we have x now. So erase this, and let's look to see if in any of the other 2 triangles we have 2 of the 3 sides. When I look at triangle number 1, z has the right angle, so z is the hypotenuse. I just get that z squared is 6 squared plus y squared, which is 2 unknowns. And when I look at the whole triangle, the right angle is here. This is 10. This is z. And this one is y plus 8. Part of it's y. The rest of it is 8. Y plus 8. Well, that tells me that 10 squared plus z squared is y plus 8 squared. But both of them have 2 unknowns. But you know what? This is another way of writing z squared. And if I put that other way writing z squared right here, this second equation will only have y's in them. 10 squared, which is 100, plus z squared, which is 6 squared, 36, plus y squared. This is equal to y plus 8, all squared. Well, y plus 8 all squared. You have y squared. You multiply y and 8 and you double that. Y times 8 is the same as 8 times y, and you double it. You get 16y, and you square their 8. and you get 64. Okay. First thing I'll notice is the y squares cancel out on both sides. So I have 136 is equal to 16y plus 64. Well, what number, when you add 64 to it, gives you 136? And the answer to that question is what 16y would be. And the answer is 72. And 16 times 9.5 is 72. Divide both sides by 16, get y. 8 goes into both of these numbers. You need to know your 8 table. 8 times 9 is 72. Like I said, 8 times 9 is 72. And 8 times, it's 8 times 9 divided by 8 times 2. And the 8's cancel. Like I said, y is 4.5. Y is 9/2. Okay, but we need to know, so now we have y. It's 9/2. But we need to find z. Well, here's a way of finding z if you know y. Because you could find z squared using that formula, and then from there you get z. Z squared is 6 squared, 36, plus 9/2 squared, 36, plus 81/4. Well, when it comes to the 36, if I multiply it by 4/4, that's allowed, because I only multiplied by 1. And the reason I want to do that, because in addition, I have to have the same denominators. And once I do, I keep it. 4 times 36 is 144, plus 81 is 225/4. And whenever you get answers like this, that z squared is 225/4, and it's from a textbook, you start feeling good that you didn't make a mistake. Because if I take the square root of the left side, I get z. If I take the square root of this fraction, I take the square root of the top, which is 15. And I take the square root of the bottom, which is 4. The fact that I knew the square root of 225 and I knew the square root of 4, it made me feel like I knew what I was doing. Okay, now one last thing. It would be really nice if we knew what that whole length was. So simple, I can sneak it on top here. Okay, somebody asks you, what two numbers add up to 3.5? You should say 3 plus a half. And what's 3.5? What's 3 plus a half? Let me not put it on the top because it doesn't come out so well. How much is 3.5? The answer is 3 plus a half. How much is 3 plus a half? It's 3.5. How much is 8 plus 9/2? You should say it's 8 and 9/2. And one last thing. If you multiply the 2 and the 3, you get 6, and you add 1. That fraction is 7/2, which is 3.5. 2 times 8 is 16, plus 9 is 25/2. The whole thing is 25/2. I mean, of course, you could have said this is 8, this is 4.5, 8 and 4 is 12, 8 and 4.5 is 12.5, which is another way of saying 25 over 2. Either one is okay. I'll say 12 and a half. So we have everything listed on that triangle. The small triangles, the big triangles, everything. And we use the Pythagorean theorem, which is basically the distance formula. It's basically just the distance formula. How would you show that if these are the three vertices of a triangle, how would you show or show that these vertices form an isosceles triangle? Well, if I call this point A and point B and point C, well, I can find the distance between A and B. I can find the distance. It's meaningful to find the distance between A and C. And the third distance is between B and C. That is, I find all the distances possible. All the possible distances I find. And I show that two of them are the same. The distance between A and B, let's code it that way, is equal to the square root. Well, from -2 to 5, they're different signs. Take absolute value. 2 plus 5, 7. The absolute value of -2 is 2. The absolute value of 5 is 5. Plus, from 1 to 5 is 4. Square it. So you get 49 plus 16 is 65. The square root of 65, which cannot be broken down. What about the distance between A and C? Now, I want to talk before I get this one. If you come to know that this triangle has side as 3, and this one has side as 3, and this one has side as 3, or even if that was outright given, that's an isosceles triangle. Okay, it is an isosceles triangle. I absolutely agree that we can say a stronger statement. We can say it is an equilateral triangle. That's the strongest statement. What I'm getting at is, under the definition of isosceles triangle, it says a triangle is said to be isosceles if two sides are the same length. You know what? These are two sides. Here's a triangle. Here are two sides, and you know what? They're the same length. It doesn't go on to say, but they're not all three the same length. Okay? We can say a stronger statement if all three of them are the same. Notice I didn't say we have to say they're equilateral, the strongest statement. Even if all three sides are the same, it is an equilateral triangle. On an exam, if you have multiple choice, this triangle is a scalene, isosceles, equilateral. I would pick equilateral. If I was in a really bad mood, I might pick isosceles and then argue with the grader saying it's isosceles. Okay? And if the person's going to be fair, they have to say you're right. It is also isosceles. Now, why am I saying it right here and right now? And the reason is, and I don't know if it's going to happen, but if the distance between A and C is square root of 65, I can stop. Because I know that at least two of the sides are equal. Okay, A to C. From -2 to -1 is 1. Plus, from 1 to -7, +1, -7, positive, negative, 1 plus 7, 8. Get 1 squared, which is 1, plus 8 squared is 64. Look at that. We got the same. We are done. I couldn't care less what BC was. But you're dying to know what it is. We'll figure it out. Let me tell you, this is on a test. However long it takes me to continue from right here. It's test time. It's wasted time. You could have done another problem or checked another problem. B to C, from 5 to -1. They're different signs. 5 plus 1, 6. Square it. From 5 to -12. Sorry, from 5 to -7. That's 12. Well, already 12 squared is more than 65. It's 144. 36 plus 144, if I'm not mistaken, that's 180. "36 times 5 is 180. This is square root of 36 times 5. 36 is the largest number that I know the square root of. Which numbers do I know the square root of? 2 squared, that is 4. 3 squared, which is 9. 4 squared, which is 16. 5 squared, which is 25. 6 squared, I know the square root of. I know the square root of 49. I know the square root of 64, etc. For example, the square root of 25 is 5. The square root of 9 is 3. The square root of 36 is 6. 6 times the square root of 5, which I don't know. Okay, but all of this was, in my opinion, wasted time. If you're going to draw it, maybe you're required to draw it, and you have graph paper, and you draw it precisely correctly with a straight edge ruler and graph paper. Well, whichever two sides look the same, calculate those two first. Let's try one more. Let's talk about the points 1, 2, 4, 6, and 10, 14. I want to show that these points are collinear. Show that those 2 points are collinear. Actually, I don't think they spell it with a dash. They spell it with 2 L's. Show that those 3 points are collinear. Well, what does it mean for 3 points or 4 points or 24 points to be collinear? Very simple answer. They lie on the same line. So basically we have 3 points, A, B, and C. So here's point A, and here is point B, and maybe point C's up here. Well, here's the deal. If this distance plus this distance does not equal that distance, they're not collinear. But you know what? If they really do lie on one line, then this distance of 2 plus that distance of 4 from A to C should be 6. And that's going to be our strategy. But here, we'd really like to have an idea where these points are. Or in other words, okay, well actually, it doesn't matter. Here, it doesn't matter. If you get 2, 4, and 6, or 2, 6, and 4, you say, yeah, those two distances add up to the third. So that's what we're looking for. If two of the distances, there's 3 distances to compute. A to B, we can compute the distance from A to C, and we can compute the distance between B and C. And if 2 of those distances add up to the third one, then we're okay. Now, for the record, if you think I walk around knowing these facts, you're mistaken. I argue it through right here and now for myself, for you. Okay, you should have some maturity to see that. If they're not collinear, these being the 3 points, if they're not collinear, well then, you know the shortest distance between A and C, and it's not 3B. It is a straight line. That is AB plus BC, that must be longer. And that's all we need to do in this problem. The distance from A to B, square root. From 1 to 4, 1 up 3. Plus, from 2 to 6, 1 up 4. And I jump on this one. 3 squared plus 4 squared is 5 squared. And the square root of 5 squared is 5. And I'm like, thanks for giving me favorable numbers. From A to C. From A to C. Well, from X goes from 1 to 10. 1 up 9. Okay. That's already more than 25. And Y goes from 2 to 14 and 1 up 12. Again, I see 3 squared times 3 squared is 9 squared, plus 3 squared times 4 squared, which is 12 squared. And I know that 3 squared plus 4 squared, I notice like I know my name, is 5 squared. So I can take the square root separately. The square root of 3 squared is 3. The square root of 5 squared is 5. I get 15 equals 15. So the other distance has to be 10 or 20. Where am I getting these numbers from? Well, either that second side is the longest, the side that I haven't computed is the longest one, and it's 20, or the second side is not the longest one, and 15 is the longest one. So that second side has to be 10. Okay, B to C. From 4 to 10, 6. Square it. Plus 6 to 14 is 8. Square it. And you know what? I can pull out, these numbers are even. So I know I can factor out a 2 squared, and 2 times 3 is 6. So 2 squared times 3 squared is 6 squared, plus, again, 4 squared. 2 squared times 4 squared is 8 squared. Well, this is the square root of 2 squared times 5 squared, which is the square root of 10 squared. And the square root of 10 squared is 10. So, yep, it works. 5 plus 10 is 15. They are 15, excuse me. They are definitely collinear. Since 5 squared plus 10 squared equals 15, the 3 points are in fact collinear. Can we prove that? Okay. Let's try another problem. I'm going to give you 2 points. I'm going to tell you that a third point is equidistant from these 2 points. But I'm only going to give you the x value of that third point. So this point is 1, 4. And the other point is 10, negative 3. And there is this other point that is equidistant. And all I'm telling you is the x value is 5. What is the y value? Well, this distance must equal that distance. Well, what is this distance? What is that distance? Call this D1, call that D2. Well, D1 is, now here we really have to use the formula more exact. From 1 to 5, the change is 4, plus from 4 to y, or y to 4, the change is y minus 4, or 4 minus y. But when you square it, they're the same. So you get 4 squared is 16 plus y minus 4 squared. You get y squared, this product, which is negative 4y times 2, negative 8y, plus 4 squared, 16. That is, we get y squared minus 8y. 16 plus 16 happens to be 32. That is D1. Let us compute D2, set them equal, and solve for y. We'll have one equation at that point and only one unknown. D2. From 10 to 5, it's plus 5, minus 5, who cares? Plus y minus a negative 3, which is y plus 3. Five squared is 25 plus y plus 3 squared. Get y squared plus y times 3, which is 3y doubled, 6y, plus 3 squared, which is 9. So we get y squared plus 6y plus 25 plus 9 is 34. So we conclude that the square root of y squared minus 8y plus 32 is equal to the square root of y squared plus 6y plus 34. Well, if the square root of two things are equal, what's underneath the square root signs must be equal. That is y squared minus 8y plus 32 is y squared plus 6y plus 34. First thing I would do is cross off the y squares and be happy that I don't have a quadratic equation to deal with. I'll bring all the y's to the side that has the most. The left side has negative 8y's, the right side has positive 6y. So I'm going to bring all the y's to the right side by adding 8y's. And while I'm at it, I'm going to bring the numbers to the left side by taking away 34 from both sides. So negative 2 is equal to 14y. Divide by 14, get y. Divide by 14, get negative 1 over 7. 2 goes into both of those numbers. The top one negative 1 time, the bottom one 7 times. Minus some silly error, that is the value of y. Negative 1 over 7, and this completes the section on the distance formula.